Good morning, everyone. It is a pleasure and an honor to participate in the AMPS, a Focus on Pedagogy 2026 event, and to share this research with an international academic community interested in pedagogy, innovation, technology, and educational transformation. First, I would like to thank AMPS and the organizers of this academic space for the opportunity to present our work and to engage in dialogue about the future of education, evidence-based decision-making, and emerging technologies. The title of our presentation is Artificial Intelligence and Data Science for Smart Educational Project Management, a literature-based model for evidence-based decision-making. This paper was developed by Sergio Zavala Vargas, Nelson Torrefio Sanchez, and María Jaimes Quintanilla from Corporación Universitaria Minuto de Dios, Uniminuto, Colombia. The study addresses a central question for contemporary educational institutions. How can artificial intelligence and data science contribute to better planning, monitoring, and decision-making in educational project management? The purpose of this presentation is to explain the conceptual background, methodological route, main findings, and proposed model that emerged from the literature review and pilot implementation. Before presenting the study, I would like to briefly introduce the authors. Sergio Andrés Zabala Vargas is an electrical engineer, holds a master's degree in project management, and a PhD in educational technology. He teaches in the project management specialization program at Uniminuto and has 20 years of teaching experience. María Alejandra Jaimes Quintanilla is an industrial engineer, holds a master's degree in quality and comprehensive management, and is a professor of industrial engineering at Uniminuto. Priest Nelson Torrefio Sanchez is a chemist, pharmacist, theologian, ethics professor, researcher, AI maker, mentor, and ISO 9001 to 2015 quality auditor. Together, the team integrates education, project management, engineering, The motivation for this research comes from a growing problem in higher education institutions. Educational institutions are increasingly expected to become more efficient, transparent, inclusive, and responsive. They must manage academic programs, research projects, innovation initiatives, student retention strategies, quality assurance processes, digital transformation projects, and institutional improvement plans. However, many of these processes are still managed through fragmented systems, manual procedures, isolated databases, and decisions based more on intuition than on integrated evidence. This situation creates several challenges. First, project information is often dispersed across different departments. Second, decision-makers do not always have real-time indicators. Third, project risks are usually detected too late. Fourth, institutional learning is limited because previous project data are not systematically analyzed. Finally, educational leaders may have difficulty prioritizing resources and evaluating the real impact of their projects. At the same time, artificial intelligence and data science are expanding rapidly in education. However, most applications focus on teaching, learning analytics, adaptive learning, or student performance prediction. Less attention has been paid to how these technologies can improve the management of educational projects and institutional decision-making. This gap motivated our study. The starting point of this paper is that educational project management has become increasingly complex. Higher education institutions operate in environments characterized by digital transformation, budget constraints, accountability demands, quality assurance processes, accreditation requirements, and social expectations. In this context, project management is not only an administrative function, it becomes a strategic capability. Educational projects may involve curriculum innovation, virtual education, infrastructure, student support, research development, employability strategies, teacher training, community outreach, or institutional transformation. Each of these projects requires planning, monitoring, resource allocation, risk management, evaluation, and reporting. Nevertheless, traditional project management practices in education frequently face limitations. These include delayed reporting, low interoperability between information systems, insufficient data culture, limited predictive capacity, and weak integration between strategic planning and operational execution. Artificial intelligence and data science offer important possibilities to address these challenges. AI can support prediction, classification, automation, recommendation, and decision support. Data science can help transform institutional data into actionable information. Together, they can strengthen project planning, risk detection, resource optimization, and evidence-based governance. The paper proposes that smart educational project management should not be understood only as the use of technological tools. It should be seen as an integrated model that combines data, people, processes, ethics, governance, and institutional strategy. The main objective of this study was to develop a literature-based model that integrates artificial intelligence and data science to improve educational project management and evidence-based decision-making in higher education institutions. More specifically, the study sought to achieve 4 complementary purposes. First, to identify the main contributions of artificial intelligence and data science to project management and educational management. Second, to analyze the barriers that limit the adoption of these technologies in educational institutions, especially in Latin American contexts. Third, to propose a conceptual and operational model for smart educational project management based on AI and data science. Fourth, to explore the potential impact of this model through pilot implementation in 3 educational institutions. The central research question was, how can artificial intelligence and data science support a smarter, more transparent, and more evidence-based model for educational project management? This question is relevant because educational institutions need to move from fragmented decision-making to integrated, predictive, and ethically governed project management systems. The theoretical framework of the study is organized around 4 pillars. The first pillar is educational project management. This refers to the planning, execution, monitoring, evaluation, and closure of projects in educational institutions. In this study, project management is understood not only as a technical process, but as a strategic practice that supports institutional improvement. The second pillar is artificial intelligence. AI includes machine learning, natural language processing, predictive analytics, decision support systems, and automation tools. In educational project management, AI can help identify patterns, forecast risks, classify projects, detect delays, and recommend actions. The third pillar is data science. Data science involves data collection, cleaning, integration, visualization, modeling, interpretation, and communication. In education, this is particularly important because institutions generate large amounts of data, but do not always transform them into strategic knowledge. The fourth pillar is ethical and responsible governance. The use of AI and data science in education requires transparency, privacy, fairness, accountability, and human oversight. A smart model cannot rely only on algorithms. It must include ethical principles and institutional rules that guide responsible implementation. Together, these 4 pillars support the proposed model: project management, artificial intelligence, data science, and ethical governance. The methodology followed a dual approach. The first component was a literature-based analysis. This involved reviewing academic and institutional literature related to artificial intelligence in education, data science, learning analytics, educational management, digital transformation, project management, and AI governance. The review allowed us to identify trends, conceptual gaps, implementation challenges, and promising applications. Particular attention was given to the limited number of studies that connect AI and data science with educational project management, rather than only with teaching and learning. The second component was an applied empirical exploration. This involved pilot implementation in 3 educational institutions. The aim was not to present a large-scale experimental validation, but to explore how the model could operate in real institutional contexts. Quantitative data were used to assess technological maturity, project management efficiency, decision-making time, and the perceived usefulness of the proposed model. Qualitative information was collected through interviews, expert judgment, and institutional feedback. This dual approach made it possible to connect theory and practice. The literature review provided the conceptual foundation, while the pilot implementation offered evidence about feasibility, applicability, and potential impact. The results from the literature review show that artificial intelligence and data science can support educational project management in several ways. First, they improve project planning by using historical data to estimate duration, resources, costs, risks, and expected outcomes. Second, they strengthen resource allocation by helping decision-makers identify priorities and distribute resources according to project needs, institutional goals, and performance indicators. Third, they support risk prediction. AI-driven analytics can detect patterns associated with project delays, low execution, budget deviations, or weak stakeholder participation. Fourth, they enable real-time monitoring through dashboards, indicators, alerts, and visual analytics. Fifth, they contribute to institutional learning. When project data are stored, analyzed, and reused, educational institutions can learn from previous initiatives and avoid repeating the same mistakes. The literature also shows important barriers, including low data integration, limited analytical culture, lack of specialized talent, resistance to change, ethical concerns, and insufficient governance frameworks. Therefore, the main result of the study is not only the identification of technological opportunities, but the formulation of a model that organizes these opportunities into a coherent institutional framework. The proposed model is called SEPM-AI, Smart Educational Project Management with Artificial Intelligence. This model seeks to guide educational institutions in the progressive adoption of AI and data science for project management. The SEPM-AI model is based on the idea that educational project management can become smarter when institutions integrate four core elements: reliable data, analytical tools, human decision-making, and ethical governance. The model is not designed as a purely technical system. It is a framework for institutional transformation. It recognizes that AI and data science can only create value when they are aligned with strategy, people, processes, and educational purposes. The model includes three major components: the foundation, the engine, and the execution layer. The foundation refers to the institutional conditions required before implementing AI. The engine refers to the analytical and technological core of the model. The execution layer refers to how AI-driven insights are transformed into project decisions, monitoring, and improvement actions. This structure helps institutions avoid a common mistake: adopting tools before developing data culture, governance, and strategic clarity. The foundation of the SEPM-AI model includes the basic institutional conditions required for responsible and effective implementation. The first condition is data governance. Institutions need clear rules about data ownership, data quality, access, privacy, security, and ethical use. Without data governance, AI systems may generate unreliable or biased outputs. The second condition is technological infrastructure. Educational institutions need platforms that allow data collection, integration, storage, visualization, and analysis. This does not necessarily mean complex or expensive infrastructure. It means having interoperable and reliable systems that support project management. The third condition is organizational readiness. AI adoption depends on institutional culture, leadership support, staff training, and willingness to use evidence in decision-making. A technically advanced system will fail if users do not understand it, trust it, or use it. The fourth condition is strategic alignment. AI and data science must be connected with institutional goals. They should not be used only because they are innovative, but because they help solve real institutional problems. The foundation component is essential because many digital transformation projects fail when technology is introduced without preparing the organization. In this model, the foundation acts as a maturity layer. It helps institutions identify whether they are ready to implement AI-driven project management and what capacities must be strengthened before scaling the model. The engine of the SEPM AI model is the analytical and technological core. This engine includes data science processes and artificial intelligence tools that transform raw data into useful knowledge for project management. The first element is data integration. Educational institutions generate data from academic systems, financial systems, learning management systems, research platforms, quality assurance processes, and administrative reports. The model proposes integrating these data sources to obtain a more complete view of institutional projects. The second element is descriptive analytics. This allows institutions to know what is happening in their projects, levels of execution, delays, budget use, task completion, stakeholder participation, and performance indicators. The third element is predictive analytics. This is where AI becomes especially valuable. Machine learning models can estimate the probability of delay, identify projects at risk, anticipate resource needs, and detect early warning signals. The fourth element is prescriptive support. The model does not only describe or predict, it also supports decision-making by suggesting possible actions, priorities, or mitigation strategies. The fifth element is explainability. AI outputs must be understandable for educational leaders and project managers. If users cannot interpret why a system recommends an action, trust will be limited. Therefore, the engine combines data integration, analytics, prediction, recommendation, visualization, and explainability. Its purpose is not to replace human judgment, but to enhance it. The execution layer explains how insights generated by the model are transformed into institutional action. The first process is project prioritization. Institutions can use data to classify projects according to urgency, strategic relevance, expected impact, feasibility, and risk. The second process is project planning. AI and data science can support schedule estimation, resource planning, task sequencing, and risk assessment. The third process is monitoring and control. Dashboards and alerts can help project managers detect deviations in real time and take corrective actions before problems become critical. The fourth process is decision-making. The model supports decision-makers with evidence, scenarios, and recommendations. However, the final decision remains human, contextual, and ethically guided. The fifth process is evaluation and learning. After a project is completed, data should be analyzed to identify lessons learned, success factors, barriers, and opportunities for improvement. The execution layer closes the gap between analytics and action. It ensures that AI and data science do not remain as technical exercises, but become part of institutional management. In this sense, the SEPM AI model promotes a continuous improvement cycle: data collection, analysis, prediction, decision, action, evaluation, and learning. The pilot implementation was carried out in 3 educational institutions. The purpose was to explore the usefulness of the SEPM AI model in real organizational contexts and to assess its potential contribution to educational project management. The results showed 3 main impacts. First, there was an improvement of up to 25% in project execution efficiency. This was associated with better planning, clearer indicators, improved task monitoring, and greater visibility of project progress. Second, there was a 30% reduction in decision-making time. This improvement was related to the availability of integrated information, dashboards, and more structured criteria for prioritization and action. Third, institutional participants reported better capacity to identify risks and monitor project progress. The model helped move from reactive management to more anticipatory management. These results should be interpreted as exploratory and contextual, not as definitive generalizations. However, they provide relevant evidence about the potential value of integrating AI and data science into educational project management. The pilot also confirmed that technology alone is not enough. The best results were observed when institutions combined data tools with leadership commitment, clear processes, and collaborative work among academic and administrative teams. The study allows us to conclude that artificial intelligence and data science can significantly contribute to educational project management when they are implemented through an integrated and ethically responsible model. The first conclusion is that educational institutions need to move beyond fragmented data practices. Smart project management requires integrated information systems, clear indicators, and analytical capacities. The second conclusion is that AI can improve planning, monitoring, risk prediction, and resource allocation. However, these benefits depend on data quality, institutional readiness, and governance. The third conclusion is that data science strengthens evidence-based decision-making. It helps institutions interpret what is happening, anticipate what may happen, and decide what actions should be taken. The fourth conclusion is that ethical governance is essential. AI must be transparent, explainable, fair, and aligned with educational purposes. The use of AI in education should not reduce human responsibility. On the contrary, it should support better human judgment. Therefore, the SEPM AI model contributes to a more strategic, transparent, and sustainable approach to managing educational projects. As a final reflection, this study contributes to the field in three ways. First, it expands the discussion on artificial intelligence in education. Instead of focusing only on students, learning analytics, or classroom applications, it examines how AI and data science can support institutional management and project governance. Second, it proposes a literature-based model that can be adapted to different educational contexts. The SEPM AI model is not a rigid technological product. It is a flexible framework that institutions can adjust according to their maturity, needs, resources, and ethical principles. Third, the study offers practical evidence from pilot implementation in 3 educational institutions. The reported improvements in execution efficiency and decision-making time suggest that smart educational project management is not only a theoretical possibility, but a feasible institutional strategy. Future research should deepen the validation of the model through longitudinal studies, larger samples, comparative designs, and more detailed analysis of data governance, algorithmic transparency, and institutional adoption. In conclusion, artificial intelligence and data science can help educational institutions become more anticipatory, evidence-based, and responsive. But this requires a human-centered approach, where technology supports institutional purpose, educational quality, and social impact. This study is supported by several academic and institutional references. The discussion on artificial intelligence in education is informed by authors such as Zhang and Aslan, Chen and colleagues, and UNESCO's guidance on AI and generative AI in education. The data science perspective is supported by Kelleher and Tierney, Stoyanov and Daniel, and studies on big data and analytics in higher education. The project management perspective is connected with the Project Management Institute and recent research on AI in project management, including Hughes and collaborators. The ethical and governance dimensions are supported by Khosravi and colleagues, as well as broader discussions on explainable AI, privacy, accountability, and responsible digital transformation. These references helped us frame the SEPM AI model as both a technological and institutional contribution. To close, we would like to thank AMPS and the organizers of this event for creating a space to discuss pedagogy, innovation, and the future of education. We also thank Cooperación Universitaria Minuto de Dios, Uniminuto, for supporting research, interdisciplinary collaboration, and international academic participation. Thank you very much for your attention. We hope this work contributes to the conversation on how educational institutions can use artificial intelligence and data science responsibly to improve project management, decision-making, and institutional transformation.